excited for you guys because you guys are actually going to learn something that's truly, truly pre-calculus concepts. Because the functions involved with pre-calculus involve what we call rational exponents. Now, you have your note guide in front of you. I don't want you writing jack right now for like the first 3 minutes. I just want you to pay attention. We know that, let's see here, we know that from junior high school that if you have 2 to the second power, that means, right, 2 times 2, which becomes 4. Thank you, Rodriguez. Now watch this. We know that 2 to the 0 power, like Perez said earlier, is what? Nice. We know that 2 to the negative 2 power means 1 over 2 to the second, which means 1 over 4. We know that. Okay, so far so good. Now, what if we had 2 to the 1/2 power? That's where I'm headed today. What we call rational exponents. The word rational in math means a number that can be communicated by a fraction. Believe it or not all numbers can be communicated by a fraction. So we call this a rational exponent. What the heck does that mean? Well, believe it or not, it means this. Ready? Put your seatbelt on. Put them on. No, it's good. It means this. The bags deploy. I trust you've seen this somewhere in your math journey prior to Mungia or maybe with Mungia. What the heck does square root of 2 mean? What does it mean, square root? Nice. Exactly. Couldn't have said better myself. A number multiplied by itself that gets to 2. Now, is there a number multiplied by itself that gets to 2? Exactly? No, there isn't. Well, that's a philosophical debate. Because if I punch this in the calculator, it goes on to an infinite decimal. Where it ends, you know not, neither do I. But some philosophers would argue that there is a mind out there that does know where it ends and knows exactly what the square root of 2 is. You want to call that mind an alien? You want to call that mind God? You want to call that mind Brahma? I don't know. What do you want to call it? But some philosophers argue, hey, there isn't. If you punch the square root of 2, we don't know where it's at, but there is someone who does. Now, that's a separate discussion. All I want to communicate right now is when you have a rational exponent, it actually means the root of a number. Watch this. Let's go 4. Square root of 4. So 4 to the 1/2 would be the square root of 4. In this case, there is such a number, right? 2. So 4 to the 1/2 power becomes 2. Because 4 to the 1/2 power means the square root of 4. So far, so good. Now, you have your note guide in front of you. Watch what we got. Look at the top of the paper. Rational exponents. Now, go ahead and put a little arrow on top of your paper on rational and just put fraction. That's just a fancy word for a fraction. A rational number is just a fraction, please. Okay? A number that can be expressed as a fraction is a number that is rational. Look what it says here. Let a to the 1 over n power be an nth root of a. So think of what I just did right now. 2 to the 1/2 power was the square root. So there's really a 2 here, and we call it the square root. We could also call it the second root, but we don't bother to write a little 2 number there. But there's actually a 2 there that you have to realize is always there. So when we talk about the square root or the third root or the fourth root, the fifth root, it can get it as big as you want. We just name it the nth root. So that denominator is going to be the index to a number a. So right here, let's see. Let's go in the notes actually. So notes section. Let's go ahead and Go to write a, the nth root of a, some number a. Go to write the nth root of some number a on the notes. Go ahead and put an arrow on the end and go ahead and write the word index. So far, so good, Beltran? All this is going to be equal to a to the 1 over nth power. So this is the key to the whole lecture today. I'm not going to cover too much, but this is the main course right here, so to speak. Everything else is like side dishes and dessert. This is the main course. If you can get that, look, the nth root of a number is the same as a to that 1 over nth power. That's it. I'll give you another example off to the side. Kind of write small because I'm going to give you a lot of little examples here. How about x to the 1/3 power? Stay with me, Ayala. X to the 1/3 power. Is going to be, hit it more, the square root? The third root, watch this now, the third root of x. That's it. You just take the denominator becomes your index. So far, so good. So that's really the essence of the difficulty. I mean, it looks crazy because we're not used to fractional rational exponents. They look scary. But all it is take that denominator. It just becomes the nth root of that number. We get another example. What is 8 to the 1/3 power? Let's do it. So the denominator becomes the root. It'd be the cube root or the third root of 8, huh? Exactly. Look at exactly. Which is asking, what is really asking? So 3 separate numbers, 3 different numbers? Yeah, so what number can you multiply by itself 3 times to get to 8?
2.
Thank you. It's 2. Do it in your mind. 2 times 2 times 2. 2 to the 3rd power is 8. Got it. Thank you, Rodriguez. Nothing too crazy, right? So far, so good? Estrada's on this. Here we go. How about q to the 1/5 power? Hit it, Rodriguez. So after 3, there's no fancy words. We'll say the 5th root. The 5th root of q. Got it. What do you guys think? So far, so good? I didn't think you're going to have this much fun with this. It's cool. My first period was all depressed and ready to cry, and you guys are like enjoying this. Seriously. All right. Maybe perhaps with the next examples, the sad faces will start being generated. Watch this. Tomorrow we're going to get into negative fractional exponents, so I don't want to give you nightmares tonight. We're just going to focus on this now. Okay? So a to the, look at the numerator and the denominator. Look at the numerator becomes a power outside parentheses. And the denominator, like I just got through explaining, becomes the index of the radical. So let me explain the logic of this rule here. The logic of this rule is actually very intuitive and self-evident. Watch what I mean here. What if I have, so if you're still in the notes section, I encourage you to write small, because I got a few more before we get to the exercises. Let's go, x to the 2/3 power. So far, so good. Watch this now. Look what I'm going to do. I'm going to follow this rule up here. I'm going to rewrite the fraction as the multiplication of two numbers, a power to a power property. In other words, watch this. Isn't x to the 2/3 the same as x to the 1/3 times 2? That's the same, huh? Look what I did. I wrote 2/3 as the multiplication of two separate fractions. 1/3 times 2 over 1. That makes sense. Right? So numerator times numerator, 2. Denominator times number 3. Cool. No harm, no foul, no blood, no stress so far. Watch this now. Can I rewrite that expression as this? Look at x to the 1/3 times 2. Isn't that the same thing too? Yeah, because 2 over 1 is still 2. Remember, power of a power property? You just multiply those puppies. Right? So far, so good. We know that. Okay. So then using some more logic, that's all math is a symbolic logic. Can I rewrite this? What I just taught? What does this mean here? X to the 1/3 power. We just got through with a previous example. What does this really mean in parentheses? The cube root of. Nice. Now look at. Done. So this meant that. Look at the logical progression. You see the logic involved here. Let's do one more. Now, if you even grabbed a teacher at this school here, and you asked them what's x to 2/3 power, they'd probably run away. It looks scary. But now you know the logic involved. You can handle it now. Let's do one more. Seriously, you have the power now to give. You got a lot of power. When math, a lot of power. It's job security too, because most people don't want to do math, let alone teach it. So if you want to make some good money, be a math teacher. I'm telling you right now, if you want to make good money, be a math teacher. It's easy. You just got to know it. It's easy. It's fun too. It's fun torturing kids. How about q to the 3/5 power? Look how nasty that looks. It looks hideous. It looks obscene. It looks gross. But you have the logical prowess and knowledge now to handle this.
The same thing you just do to the top one. So you put so it'd be equal, and then you would put.
Hit it.
You would put cube.
What's going to be cubed though? Give me what's inside parentheses first. How about this? Let me follow this. Okay, so go ahead. Q to the. I think you said cube. Okay, Q to. Give it to me.
It's gonna be one.
You're there.
No, I got this. Yeah, 1/5.
Nice. 1/5 to.
Yeah, 1/5
times.
3/1.
Thank you. So far, so good. Which is equal to q to the 1/5 times 3. That's the same thing. Which is equal. Hit it. How do you say that? Fifth root of. Hit it.
Q.
Nice.
And then 3.
We're done. Got it. So this means that. Now, like I said, tomorrow, that's pretty much my lecture. We're pretty much done. Tomorrow, we're going to get into what's q to the negative 3/5 power. That even looks more hideous and nightmarish and Nightmare on Elm Street kind of stuff. But before we do that, before we close out our notes, we're going to do the first 3 examples on that note guide. It says exercises 1, 2, and 3. What you're going to do is you're going to go, I'm going to give you 2 minutes to go grab your Chromebook, and you're going to open up to this screen here. Desmos.com. Go to desmos.com. We're going to do these together. So get to this screen. I'll give you about 4 minutes. One more time. I'm sorry. Forgive me. Good. So this would be negative 125 to the 1/3 power, which really means, translate that for me. Nice. Cube root of, hit it. Nice. Okay, now let's go to our calculator. We're going to figure out what the cube root of negative 125 is, because I'm pretty confident none of you know what that is. Unless you want to prove me wrong. That'd be kind of cool. Actually, you wouldn't. Never mind. Uh-oh. All right. Let's punch in the cube root of negative 125. Can anybody see the nth root button on your calculator? Stay with me, Gonzalez. Where's the nth root? Can someone spot it out for me? Right there, huh? You see that? You guys see the nth root? Press that puppy. It's asking what the value of n now is on your calculator. What is the value of n? Thank you. Hit 3. Then click inside the radicand. What are we going to put in there? Awesome. Hit negative 125. Hit enter. It's negative 5. Go ahead and go back to your, write down your notes so it's become negative 5. Was that easy or what? Telling you. All right, Mr. Gonzalez, set up number 2 for me. Hit it. You're going to get number 3 for me, Morales, so you can be working on that one for now. So, yeah, so Gonzalez, hit number, how would I set up number 2? Nice. Nice. Which becomes, I like the name, square root. Square root, notice, little FYI, you don't have to put the two index, because when we write square root, everyone knows there's a 2 there. We just don't bother to write it, so it's square root of negative 400. Let's go to our calculator. Let's do it. Now, notice your calculator, it has a square root button. You don't have to put the index button. You with me? Look at, there's your square root button. That's an automatic 2 index. So let me go ahead and square root of negative 400. What does yours say? Same thing. Undefined. Things that don't exist don't have definitions. So why would the square root of negative 400 not exist? What the heck is going on? Why is it undefined? Let's go ahead and write undefined, by the way. So go ahead and put equals undefined. Can someone tell me why? Negative. Think of, there'd be no number times itself that can possibly be a negative number, whether it's 400 or any negative number. What number times itself would become a negative number? Nothing. That makes sense? So even a negative times a negative becomes positive. A positive times a positive becomes positive. So it'd be impossible. So that's why it's undefined. And number 3, Morales, set up number 3 for me.
64.
Uh-huh.
With the exponent of 1/6.
The 1/6 power.
Which equals 6 to the square root of, 6 root of 64.
Awesome.
Which equals 2.
equals 2. Type that in your calculator. We're good to go. The 6th root of 64. So let me clear mine. So the n is 6. Radicand is 64. And we hit enter. So it becomes 2. It really is not that hard, huh? Tomorrow we're going to get into a little higher level.